Hello, in this video I will show you how to prove a parallelogram by using rules that we already know. Then I will end the video using doing a two-column proof. So on the previous video we were talking about parallelograms. Now we're going to prove how do we prove a polygon is a parallelogram. So let's go over that. So in order to prove a polygon is a parallelogram, first you must show that both pairs of opposite sides are parallel. So I think we kind of went over that in the other video. And then we also got to show that both pairs of opposite sides are congruent. And then we got to show both pairs of opposite angles are congruent. Then we must show that the diagonals bisect each other. And then we also have to show that one pair of opposite sides are parallel and congruent. And then we got to show that one angle is supplementary. I'll talk about supplementary to both consecutive angles. So we'll talk about supplementary just simply means 180. And yeah, I'll explain what that really means. So if you look at kind of like this little image, this is definitely a parallelogram because it satisfies all those six conditions. You have two parallel sides that are congruent, right? You see these little triangles, that means parallel, and then you have these tick marks. You have one tick mark here. This side is congruent with this side, and then you have two tick marks here. This side is congruent with this side. Uh, Now look at the diagonals. The diagonals are not congruent. This side is only congruent with this side, and then this side is only congruent with this side. So keep in mind that in a polygon, not all diagonals are the same. And also, you also need to know that these angles, so if you know what this angle is, it's congruent to this angle, but not all angles are congruent. If you know what this angle is, it's congruent to this angle. And if you add up, so if you add up this angle plus this angle, it's what's called supplementary. So let's call this angle 1 and then this angle 2. If you add up all those angles, angle 1 plus angle 2, it equals to 180 degrees. That means it's supplementary. Okay, so let's briefly let's go over this one. So this one says, are you given enough information to prove that the quadrilateral is parallelogram? So this is all they give us. Is this good enough? Is this good enough to prove that the quadrilateral is a parallelogram? Well, let's look at our sides. So this side is congruent with this side, and this side is congruent with this side. I'm going to say yes. The reason why I'm going to say yes is since both pairs of opposite sides are congruent. And then yes, opposite sides are congruent. So that was a major correct that was a major prerequisite that they specifically said that both pairs of opposite sides are congruent. That doesn't mean all sides are congruent. It just means this side must be congruent with this side, and then this side must be congruent with this side. Okay, let's look at this one. Is this parallel? Is this quadrilateral a parallelogram? It doesn't say anything about sides, but uh they don't tell us the diagonal. They don't tell that this diagonal is going to go with this diagonal. All it tells is these inner angles. So this angle is called as angle one, and this is congruent to angle two. And then this angle here is like angle three, and this is angle four. This angle is congruent with this angle, and the angle three is congruent to angle four. Why is that? Is because they're vertical angles. So uh vertical angles is like those crisscross. If you recall, here's angle one, here's angle two. Angle one is congruent to angle two, and then angle three is congruent to angle four. In our prerequisite, it said nothing about vertical angles, right? Um, so I'm gonna say no, because it didn't. I think the opposite sides must be parallel and congruent. That's like a big factor. So I'm gonna say no. It's showing vertical angles are congruent. So no, it's in our so no, it's in our list, so it can be any type of so no. It could be any type of quadrilateral. Okay. Let's move on to the third one. Um, Based on this, can we say that this quadrilateral is a parallelogram? So they don't tell us anything about size, so they only tell us about these angles. Um, they say that this angle 120, this is angle 60, this is angle 120. They do say that opposite angles must be parallel congruent, and then these two angles should be what's called supplementary. So does if you add up this angle plus this angle, is that supplementary? Meaning do they add up to 180? Yes, so that was one of the prerequisites of a quadrilateral being a parallelogram. So I'm going to say yes, because if you add up this angle plus this angle, and we know that this angle, they don't tell us this angle, but we know it's 60 because this angle is congruent with this angle. And then you can see if you add up 120 plus 60, it's 180. I'm going to say yes. So they're, this angle and angles is consecutive, and then opposite angles are congruent. Okay, let's move on to 4. So we have this parallelogram, and they tell us that these two sides are congruent because this side is 16.2 and then this side is 16.2. What else do they tell about this side? They are parallel. Do you see this arrow? This arrow represents parallel. So I'm going to say yes. What about this fifth example? Is this quadrilateral a parallelogram? What did they give us? They tell us a few things. They tell us angles in these diagonals line segment, right? So this line segment or this diagonal is congruent with this diagonal. How do I know? Because there's one tick mark. That means congruent. And then this diagonal line segment is congruent with this diagonal side line segment. And how do I know? Is because they have two tick marks. So not all of the diagonals are congruent. So yes. And then this angle, they talk about angles. This angle is congruent with this angle, and then this angle is congruent to this angle. Basically, what they're really saying is this entire angle is congruent to this entire angle. So, yeah, that I'm going to say yes because, yes, since since diagonals bisect and alternate interior, that means we have parallel lines. Okay, let's look at example 6. Is this quadrilateral a parallelogram? So I know that this angle right here is congruent to this angle because there's one tick mark. And they only say that this angle is 180 minus n. And then this, oh, I didn't write this down, but this angle here is called n. I think what it is, that opposite angles are congruent. So this angle is congruent to this angle. And also, they say that this angle here is 180 minus n. Yes, that means it's supplementary. So, yes. So the reason why is because opposite angles are congruent, meaning this angle is congruent with this angle. Yes, opposite. And the other reason also we have an angle supplementary. Both consecutive angles. Okay, let's look at this example. So this question says, is each piece of information alone sufficient to conclude that quadrilateral WXYZ is a parallelogram? And here you have this quadrilateral, and what do they say? They say, so yeah, here we have this quadrilateral. So question 7 says, is the line segment ZW is congruent to YX and is the line segment ZY congruent to WX? So first locate ZW. ZW is right here. Should that be congruent to YX? And then should ZY be congruent to WX? I think so, right? That's like saying if you kind of draw the image, this side must be congruent with this side, and then this side must be congruent with this side, right? So I'm going to say yes because opposite side must be parallel, and they also must be congruent. So I'm going to say yes. What about question 8? V is the midpoint of both the line segment WY and line segment XZ. Is that true? V is the midpoint of both line segment WX, I mean WY and line segment XZ. So here's V right here. Is this true? Is V the midpoint of both the line segment WY and line segment XZ? Yes, I believe so. Um, yes, since diagonals bisect each other. So, if you kind of draw this image right here, it's like saying, okay, let me draw the image. Now, diagonals doesn't necessarily mean all, here, can we draw the diagonal? Here's V. They're saying that this side must be congruent with this side, and then this side must be congruent with this side. And that's true. It doesn't mean, yeah, that's true. It doesn't mean all the diagonals are congruent. So I'm going to say yes, since uh, diagonals bisect each other. It's cool. Question 9 says WXYZ is equilateral. Let's see, does that, so are they saying that all the sides are, this was what we're originally given. So is WXYZ, is that equilateral? Meaning, does all the sides equal the same? They don't tell you anything about the side lengths, but I'm gonna say yes. Yeah, because if you look at 7, this side is congruent with this side, and this side is congruent to this side. They don't tell us any side lengths. They don't tell us any tick marks, so I'm gonna say yes. I assume that they're all sides are the same. Okay, number 10 is line segment ZY parallel to YX. So line segment is ZY. I don't think so. They have no arrows, meaning they if this arrow, if you had one arrow here and then one arrow here, and then you had two arrows here and two arrows here, yes, that would be definitely parallel. But because there's no arrows, I'm gonna say no. Okay, let's move on to 11. I think 11 is very similar to 10. Is line segment ZY parallel to WX and then line segment ZW congruent to YX? So if they are parallel, that means they also have to be congruent. There's nothing about anything that says parallel, so I'm going to say no. And also, so number 12 is line segment ZY parallel to WX and then Z line segment ZW parallel to YX. No, I don't think so because there's no arrows, so I'm gonna say no. 13 is line segment ZY parallel to line segment WX and line segment ZY congruent to WX. If they were parallel, right? If line segment ZY parallel to WX, that means they're also must be congruent. So let's just say hypothetically it had arrows, and then that means that these sides are congruent. So I'm gonna say yes. So yeah. Okay, let's move on to some actual problems. So this one says, what is the value of x? What value of x will make the polygon parallelogram? So you have this polygon, and what do we know about opposite angles? They are congruent. So this angle must equal to this angle, and then what do we know about 110 should also, this angle here should also be congruent to this angle, so this should be 110. And then this angle plus this angle should add to 180, and I know that's true because 110 plus 70 is 180. So, but we gotta find x. So we gotta focus on this angle and then this angle. We said that opposite angles are congruent, so we could say 70 equals to 3x minus 2. And then you go ahead and solve the x. So I would add 2, so that's 2, 3x. Divide this by 3, x equals 24. The other way you could do this is we said that this angle is supplementary with this angle, so you could also have said 110 plus 3x minus 2 equals to 180. And you get, uh, yeah, that will give you x equals 24 when you do the work. Okay. Okay, what about 15? Let's find x. So they only give us these two angles. What do we know about these two angles? Are they congruent or not? They are definitely not congruent. They are supplementary. So we could say if you add up this angle plus this angle, they add up to 180, right? So we could say 3x plus 1 plus 2x minus 6 equals 180. And when you clean this up, 3x plus 2x is 5x. 1 minus 5 is negative 5. So 180. And then add 5 to both sides. You get 5x equals to 185. Divide this by 5. Get x equals 37. Okay, now uh, you should do a proof. So let's finish off this video with a proof, two-column proof. So it says complete the two-column proof given that triangle ABF is congruent to triangle DEC and length FB is parallel to length EC. Prove that BCEF is a parallelogram. So I kind of drew the image. So we got to prove that BCEF is a parallelogram. So where's BCEF? So this one right here, this little thingy, or this. So just looking at it, could it be a parallelogram? Well, if you look at this shape right here, just this shape, I know that these two sides are parallel and then these two sides are congruent, and I know that this side is congruent with this side, this angle is congruent with this angle. So what can I do? So what would be my first statement? The first statement I'm going to use is what they give us. So what was given? It was given triangle ABF is congruent to triangle DEF, and that was given. Okay. And what would be another statement? They tell us that line segment VF is congruent to line segment C. Right here, VF, this side right here is congruent with this side. And how do I know? Because there's two tick marks meaning they're congruent. So we could say the line segment VF is congruent to line segment EC. And the reason why is CPCTC. The reason why, because what there's, they tell us specifically that triangle ABF is congruent to triangle DEC. That means if two triangles are congruent, that means all their sides must be congruent. So that would be CPCTC. Okay, what else could we say? We also have another given. I should have put that first, but the third given was line segment FB is parallel to line segment EC, and that was given. And then the last statement we could say is the final reason. Um, BCEF is a parallelogram, so BCEF is a parallelogram. The reason is opposite sides parallel. Opposite sides are parallel and congruent. So if opposite sides are parallel, so this side is parallel with this because of the arrow, and then this side is congruent with this side, that means it's definitely a parallelogram. So the reason would be opposite. So opposite sides are parallel and congruent, that makes it a parallelogram. Okay, so that was the last question. Yeah, I think we'll stop right here.